There. Hi, guys. We're just going to give it a minute. How you guys doing this morning? Good. So I'm doing good, thanks. I can't believe actually that we are coming up on the end of the semester. It's kind of wild. We have today and tomorrow as our lecture material, new material. We're covering chapter 3.2 today, mostly today. Tomorrow, I'm going to wrap up with a bunch of examples that I wanted to talk about. There's some concepts in the second set of examples that we'll do tomorrow that I want to make sure we get out. So we're going to go through the main bulk of 3.2 today. Don't forget, tomorrow we've got a quiz. This is our last quiz. I know you guys are all really sad about it being our last quiz. Our last quiz is tomorrow. It's on chapter 2 in our integral calculus book, 2.1, 2.2, 2.3, 2.4. It's all about taking the integrals and doing like area under the curve. That's tomorrow. That'll open up at noon. Your homework for those 4 chapter sections is due tomorrow night at midnight. And then the homework for chapter 3.2 is due on Monday. Okay, so you'll have some time to kind of let it sink in and sift through. The lecture examples for 3.2 I will scan in tomorrow and upload so that you guys will have that to reference when you're doing your homework for 3.2. On Monday, next Monday, we will go over any questions you have on homework 3.2 or any other homeworks that you want to go over. Also, we will go over any questions you have on old final exams. So, please take a look through some of the old finals and let me know what your questions are on those, but not today. We're going to do 3.2 today. What I'd like to do this morning is I'll cover 3.2 and then we'll have some time at the end and I'll answer homework questions at the end, okay, just to make sure that we have enough time to cover the material. We should have plenty of time also tomorrow to answer any questions on chapter 2 homework stuff. Okay, good. Okay, guys. All righty, so let's go ahead and get started. Chapter 3.2 is called Area in the Plane. And by plane, we're talking about the XY plane typically. Okay, so basically what we're looking at is looking at the area between 2 curves. I can spell 2 curves. So if I've got, let's say, here's my x-axis, here's my y. Say I've got some function f of x, and I've got another function g of x, and I'm looking at an interval from a to b, okay? And I'm gonna do this. When we integrate, when we look at the area in the plane, we're looking at the area between these 2 curves here. Okay, between f of x and g of x. Okay, towards the end of this lecture today, we're going to talk about things as they focus on the y-axis. This is the same premise, but we're going to first really just go into detail about stuff on f with respect to the x-axis. So how you want to think about this is, I'm going to be taking, right, this is my x-axis, this is my y-axis. You can imagine I've got my function f of x, and I'm going to go from a to b. When I calculate the area between the curve and the x-axis, right, of just f of x, and if I subtract out the area, let's see if I can draw this exactly, g of x from a to b, right? So if I've got this big function here, right, this big area block, I've got a smaller area block, I subtract out the smaller area block from the bigger area block, what I'm going to be left with is the area between these 2, okay? So that's the overall, like, kind of higher picture that we're thinking about when we're talking about the area between the 2 curves. Essentially, I'm subtracting these 2 areas, right, to get the, what's left over will be the area between them. Okay, so let's write that down. So the area between the two graphs, what is this, like our two graphs, is equal to, I'll write it like this. I'm going to go from A to B. I'm going to say our function on the top minus the function on the bottom. And this is all with respect to dx. Okay, how do we figure out what's top and what's bottom is something that we're going to discuss today. Okay, so in this case, this is going to look like A to B. I'm going to go f of x minus g of x dx. Okay, this type of problem has a lot of algebra set up. Okay, we need to figure out what's top and what's bottom. We have to figure out, do these two functions intersect each other? Okay, and then if they intersect each other within our interval, outside the interval, how does that affect our interval? Those kinds of things. Okay, all of this stuff, we need to show all of these steps to get full credit. Okay, how do I tell what's the area between the two graphs? I'm gonna write, as we do the lecture examples, I'll tell you what's required to receive full credit. What you don't have to worry about is the graphing, right? The graphing is just for you to visualize. So go ahead and graph away. You've got your graphing calculator. It's going to help you sketch it out. You can draw it on a piece of paper on the exam. You will have a question like this on the final exam, so keep that in mind. And this stuff gets used next semester in calculus too. So make sure you really kind of let it sink in about how this is actually working. Okay, and then in this case, let's write this. So f of x, oops, f of x is greater than g of x on our interval A to B. Okay, that's just why I go top minus the bottom. F of x is greater than g of x. Okay. All right, so let's go ahead. We're going to start in. I've got my lecture examples for chapter 3.2. And I'm going to take a look at example number 1. Example number 1 says, find the area of the region between the graphs of f of x equals x squared minus 4x plus 10 and f of x, g of x equals 4x minus x squared. So, and I'm going to go on the interval 1 to 3. So, I like to graph these things out just to be able to see. All right, so let's take a look. So I'm going to go x squared minus 4x plus 10 and 4x minus x squared. And I'm going to graph. So there's my f of x parabola. There's my g of x parabola. Okay, and you can see I'm going to go from 1 to 3, so that region between those two. So first of all, these functions we can see within A and B, they don't intersect each other. We're going to be able to see what that means in just a minute, okay, how we can tell algebraically. But the first thing I'm going to do is I'm going to draw this out on my page here because I like the graphs. Okay, so I've got my f of x function does this. Here's my f of x and my g of x goes like this. G of x, and I'm going to go from 1 to 3. So that's the region that I'm looking at. It helps you visualize, right? So keep that in mind. Okay, so our first question is, we would ask this, like, what are the points of intersection between these two? But we can see that they're not intersecting each other. So what we're really going to ask ourselves is, which function is greater? But as we go along in answering this question, I'm going to show you how you would find the points of intersection. Which function is greater along our interval 1 to 3? Right, which is our top function, because remember we're doing top minus bottom, so I need to know which is the top function. Okay, so what I'm going to do is I'm going to say f of x equals g of x. Okay, and then I'm going to subtract g of x from f of x and see what I get. If I get a positive number, that means that f of x is greater than g of x. If I get a negative number, that means that f of x is less than g of x. So let's go ahead and do that. So I'm going to plug this all in. So this is going to be x squared minus 4x plus 10 equals 4x minus x squared, right? F of x equals g of x. Okay, so now what I'm going to do is I'm going to subtract, right? F of x minus g of x, set it equal to 0, and then see what we get. Okay, so let's go ahead and subtract. So I'm going to add x squared. I'm going to subtract 4x, and I'm going to go ahead and add these out. So when I do this, I'm going to get 2x squared minus 8x plus 10 equals 0. Now, this is the combination of these two. Okay, so think about what happens. Let's just, we can see that they're not intersecting each other, but I'm just going to show you what that also looks like. So if I plot 2x squared minus 8x plus 10, okay, it's a parabola, x squared, right? So I go to graph it. Now watch what happens. Ooh, that's graph. So this is a function that represents the intersection of these two graphs. So where this function crosses the solutions, right, where this function crosses the x-axis, or where these functions intersect, well, this function has no solutions. It's always positive. Okay, since it's always positive, that means that they don't intersect each other. This is actually greater than 0, always positive, which means f of x and g of x do not intersect each other. But also because it's always positive, f of x is greater than g of x. Always positive means f of x is greater than g of x. If they didn't intersect each other and g of x was greater, we would have a parabola that was always below the x-axis. Okay, so then my g of x would be my upper function. Okay, just to kind of get a concept of what this looks like. Okay, so they don't intersect each other, so I don't have to worry about points of intersection along my interval, say for example, or at all. And because it's always positive, f of x is always greater than g of x. Okay, in general, but then also along our interval in particular. Okay, with that, now we can integrate from a to b. Okay, and I'm going to set it up like this. Okay, so this is the first thing I need to do to show. I would be doing this in the next subsequent problems. This would be about the points of intersection. Okay, so this is the first part. So now this is setting up integral. And we're going to evaluate. Okay, so part 1 we have to do, part 2 we have to do. So we're going to set up the integral. So remember, we're going to go from 1 to 3. We're going to say the function at the top minus the bottom dx. We just said f of x was always greater, so this is going to be f of x minus g of x dx. Okay, so I'm going to plug this in. I'm going to go from 1 to 3. F of x, x squared minus 4x plus 10 minus 4x minus x squared dx. I know we just did this. We know that it looks like this, but I'm writing it out specifically because we're going to look for this on the final exam. This is what's going to give you points to recognize, right, that you know which one's the top function, which one's the bottom function. You know the bounds of integration. We're subtracting top and the bottom, top minus bottom, okay, with respect to dx. Okay, this is required. To get full credit, you need to show this line right here, okay? Even though we know it's this, right, we just did that, but you have to show this part, okay? All right, so let's go ahead and we're going to combine terms, and then we're going to go ahead and evaluate it. So when I combine terms, I'm going to get 1 to 3. This is going to be 2x squared minus 8x plus 10 dx. I'm going to do linearity, right? So I'll do it all out this time here. So 2 from 1 to 3, x squared dx minus 8 from 1 to 3 x dx plus 10 from 1 to 3 dx. Okay, so let's go ahead and integrate that. So that's going to give us 2 times x squared. I do the power rule, which means x cubed all over 3 minus, this is 8 times x squared over 2, right? X squared over 2. 8 divided by 2 is 4, so 4x squared plus 10 times x. The whole thing is being evaluated from x equals 1 to x equals 3. You must show this line here. This is your antiderivative, okay? If you don't show the antiderivative, you won't get credit, right? So I know and we do that because we know that the calculators, like you can just, you can just feed this whole thing into your calculator and it'll give you an answer, it'll give you the number at the end. And some calculators are sophisticated enough to show you steps, but we're trying to test, you guys are engineers, you're supposed to be learning all these different steps, but we have to check that you understand. You must show the antiderivative. Okay, so to get full credit, you have to set it up, top minus bottom. what's our antiderivative, and now we're actually going to evaluate it. Okay, I'll do it out so we can see this time here. So 2/3, 3 cubed minus 4, 3 squared plus 10 times 3. This is our fundamental theorem of calculus, right? F of B minus F of A. 2/3, 1 cubed minus 4, 1 squared plus 10 times 1. Okay, number minus number, I'm going to get a final number at the end. Okay, so I think this, when I did this out, this was like 12 minus 20/3. And then at the end, the answer that I got was 16 over 3. You can give it as a fraction, you can give it as a decimal, either way is fine. Okay. But in terms of things that we need to see, okay, we need to see, right? So we're going to do this in subsequent questions. We would be factoring and getting the points of intersection. So that we need to show this step right here. Okay. I need to show my top minus my bottom, bounds of integration with respect to dx. I need to show my antiderivative, and then I need to show the answer. If you want to get full credit, you have to show all these different things. Okay. You guys good so far? Okay. So this area between the two graphs, this is true even if, let's say I have a case like this. My function f of x, this is my y-axis, this is my x-axis, my g of x is below, and I'm going to go from A to B. The area between the graphs is going to look like this. Okay. So remember, this is equal A to B top function, f of x minus bottom function g of x with respect to, so this is top minus bottom. Okay. Okay, so example 2, we're going to increase the complexity a little bit. Find the area of the region between the graphs. Looking at example 2, find the area between the region between the graphs of f of x equals x squared minus 5x minus 7 and g of x equals x minus 12. And we're going to go from -2 to 5. All right, so we've got our graphing calculators. Let's just go ahead and take a look. So I've got my f of x function, x squared minus 5x minus 7, and I've got x minus 12. And I graph it out. There's my parabola. And there's my g of x. And I'm going to go from -2, 1, 2, 3, 4, 5 to 5. Okay, so I've got intersections. My functions are intersecting each other within my interval, right? And I also have a case where I say top minus bottom, but look what's happening. My top function is my parabola, right, from here to here. And then my top function is my linear equation. And then my top function is my parabola again. So I need to go figure out our points of intersection. First, I'm going to sketch this plot because I like sketches. It helps me visualize. It gives me sort of a ballpark. Am I thinking about things correctly? And since we're not grading you on it, you can sketch however you feel like. This is my f of x. And then my linear function goes like this. I'm not going to draw this very well. There's my g of x. Okay, and then I'm going to go, this is -2. And as it turns out, this is 5. Okay, so my area, I need to do, I'll do these in different colors. So I've got this area here. So I need this point of intersection. It happened that I didn't draw this very well. It looks like it's like right about there. And then I need this area here. And I just happen to know that there isn't a subsequent area beyond that because I worked through this problem already. All right, so our sketch. Okay, the next thing that we need to do. What are points of intersection? Same process that we did in the previous example. Okay, points of intersection. So I'm going to set f of x equal to g of x, right? And then I'm going to solve. So f of x, x squared minus 5x minus 7 equals g of x, x minus 12. Okay, So then I'm going to subtract x. I'm going to add 12 from both sides. I'm going to subtract x. I'm going to add, add 12. And what am I going to get? I'm going to get x squared minus 6 times x plus 5 equals 0. Let's just see. I'm curious. So I'm going to go x squared minus 6 times x plus 5. This is a graph that represents the intersection of the two functions. Look, they intersect at this point and at this point right there, which we can see. I've got a point here and I've got a point here. Okay, so now what I need to do is I have to solve for x. I don't care how you do it. You can factor it by guess and check. You can do quadratic formula. It doesn't matter, but please check it. Please make sure if you do guess and check that you plug it in and FOIL it out. So we get x minus 1 and x minus 5 equals 0. Let's just do a quick check like I always say. So FOIL it out. So x squared minus x minus 5, minus 1x minus 5x. Okay, that means minus 6x plus 5 at the end. Okay, so we did it right. We factored it out correctly. So the points of intersection are x equals 1, x equals 5. 5 happens to be one of our bounds. Okay, this you need to show. Okay, that's part of the thing that you need to show when you're doing this. Like I said, you will have a question like this on the final exam, so make sure that you're aware of the things that you need to show in order to get full credit for it. So points of intersection are the first bit. Second part, we're going to set up our integral and evaluate. Okay, setting up the integral is part of the points that we need to show, the work that we need to show. So we have to do top minus bottom. But look at what's happening. I have to check, right? I've got this range of values. So my intervals are going to go from -2 to 1, and then from 1 to 5. Okay, so within here, I have to choose a value and plug it in. So if I choose a value, right, I did f of x minus g of x. That's just how I did it. So I'm going to choose 0 is within here. So if I plug in 0, 0, positive 5. So because I get a positive number, that means that f of x is greater than g of x. Okay. If I plug in a number, let's say I plug in, so I'm going to go from 1 to 5. Let's say I plug in 2. So this is going to be 4 minus 6 times 2, 4 minus 12 plus 5, right? It's going to give me a negative number. And the negative number means that g of x is greater than f of x. It's negative because remember we did f of x minus g of x, right? That's why it's negative. So in this case, that means g of x is bigger than f of x. So that tells us what's our top and our bottom in our bounds of integration. So -2 to 5 is my outside bounds that I was told to do things with. But look, I'm breaking it up 2 to 1 and then 1 to 5. So I don't have any gaps. I'm getting that full range of values on my interval, but I'm just setting it up into 2 different integrals. Okay, so let's go ahead and do that. All right. So our first one, we're going to go from -2 to 5. This is, we're going to go top minus bottom dx. We're going to break this up. So -2 to 1. F of x is greater than g of x. So I'm going to go like this. My f of x function, x squared minus 5x minus 7 minus my g of x, x minus 12 d of x. Okay, you may think, Jen, I already did that. Why do I have to write this again? Because we're going to be looking for it on the exam. Okay, plus my next interval, I'm going to go from 1 to 5, g of x minus f of x. So my g of x, x minus 12 minus x squared minus 5x minus 7 dx. Okay, this part here is required. This is required. Okay, make sure you have these written down, right, where you're showing top minus bottom, top minus bottom. Okay, don't just jump in and then, you know, plug it all in and then get some kind of an equation already. You have to show that you understand that's the top minus bottom and you have the correct bounds of integration. Okay, because this is part of what we're going to be looking for when we grade our final exam. Okay, so with that said, let's go ahead and add things together, and then we'll go ahead and integrate. So I'm going to go from -2 to 1. That's going to look like x squared minus 6x plus 5 dx plus from 1 to 5. It's going to be minus x squared plus 6x minus 5 dx. Different bounds of integration. Okay, so I'm adding things up. All right, so power rule says I can go, this is going to be 1/3 x cubed minus 6 times x squared divided by 2 makes it 3x squared plus 5x. Now my antiderivative, I'm going from x equals -2 to x equals 1 plus right here minus 1/3 x squared, cubed, plus 3x squared minus 5x, and I'm going to go from x equals 1 to x equals 5. Okay, this is required. Okay, and I'm going to do the fundamental theorem of calculus on it in order to see what my answers are. So this is going to look like 1/3 1 cubed minus 3 times 1 squared plus 5 times 1 minus 1/3 minus 2 cubed minus 3 times -2 squared plus 5 times -2 plus our next one, right? This is going to be minus 1/3 times 5 cubed plus 3 times 5 squared minus 5 times 5 minus 1/3 times 1 cubed plus 3 times 1 squared minus 5 times 1. Yikes, I'm running out of room. Okay, my fundamental theorem of calculus, right? I'm evaluating f of b minus f of a for my first integral, f of b minus f of a for my second integral. I'm going to get numbers, I'm going to add them all up, and my ultimate answer is going to be 113/3. I skipped all the steps about, adding things up. Okay. This part here is required too. Okay. Second interval. The second interval is negative. What do you mean? Right here. So this, how do I know that it's minus x cubed right there? Like how come that's the case? So what I did was, I'm adding these two intervals, or how did I know that it was going to be negative? So I don't actually know that it's going to be, so when I graph, let me see if I can answer your question in multiple ways. So when I graph it out, I can see part of the area goes beneath the axis, right? The more important thing is that I need to subtract top minus bottom. Okay, so my hardest part is figuring out, I got to figure out the points of intersection. And then I have to look, from my initial bound, this is my A to my point of intersection to my B. This also happens to be the next point of intersection. Okay, within this, I check, I do a value check where I plug in, I chose 0 because 0 is between -2 and 1. I plugged that into f of x minus g of x, and I got a positive number. If f of x minus g of x gives me a positive number, that means f is greater than g, right? Which is what I need to know. So that becomes my top and my bottom. Between 1 to 5, which is my second interval, right? I plug in a number, I chose 2. When I plug in a number within that range of values, I got a negative number, which means f minus g, if f minus g is negative, that means g is greater. Okay, so that means g is the larger function within here. Okay, so now when I set up, remember I'm doing top minus bottom. So I've got my different functions are going to be on the top and the bottom, depending on which interval, sub-interval I'm within. So -2 to 1, top minus bottom, f of x minus g of x, plus my next area, see it's a different interval, top minus bottom, g of x minus f of x. Okay, and then all I did was just combine like terms, right? So this part here, x squared minus 5x minus 1x minus 7 plus 12, watch out for distributing your negatives. Here I'm going to get minus x squared plus 5x plus 7. I'm going to combine all those things. So that's how I get a minus x squared, right? Plus 5x plus 1 is positive. Minus 12 plus 7 gives you minus 5. So that's where all these things, that's how that came out to be negative here. So when I integrate it, I'm just doing power rule, right? So the power rule says increase my exponent by 1, divide by the new exponent. I just did the power. It's a polynomial, so I did the power rule on this part right here. So you can see that's the antiderivative corresponding to that. This is the antiderivative corresponding to that one. And then this is, I plug it in. This is evaluating. I'll circle it right here. So if I take this bit and I evaluate it, I'm going to get this bit right here. Okay. If I take plus, see there's a plus, this bit, and I evaluate it, I'm going to get it right here. So it looks like this minus that, but that's just our fundamental theorem of calculus, where I go f of b minus f of a, capital F. Capital F of b minus capital F of a. We did that Monday, right? And then again, f of b minus f of a. So I evaluated 5. Everywhere I see an x, I plug in a 5, minus everywhere I see an x, I plug in a 1. Okay. You know, added it all up, subtracted, came out with a number at the end. Okay. I know there's a lot of pieces here that are moving around that we have to think of and keep track of. Any other questions that you guys want to ask before we move on to, we're going to increase the complexity just a little bit. Okay. Next example. Find the area, example 3, find the area of the region bounded by the graphs y equals 8 over x squared, y equals 8x, and y equals x. And they didn't give me like an A to B. I don't know what the interval I'm dealing with, right? And I don't even know what quadrant I'm dealing with here. We're going to be able to see that when we graph it. Okay, so let's go ahead and I'm going to graph that out. So let's delete this. So I graph it out. I'm going to go 8 divided by x squared, x function 8 times x function x. I'm going to plot all these out. Here's my 8 over x squared. Here's my 8x, it's linear, and my 1x, that's linear too. So I've got stuff happening on quadrant 1, quadrant 2, quadrant 3, but they wanted the area that was bounded by all 3 graphs. If we're being really good about it, we would actually specify this is in quadrant 1. But you can see that all 3 graphs have an area where they all 3 are going to intersect each other within quadrant 1. So this is the area that I'm going to be looking at right here. See that kind of like looks like a sail on a sailboat. Okay, so let's go ahead and sketch that just so we can visualize. All right, so I've got my 8x. I've got my 1x. And then I've got my 8 over x squared function. Okay, so this is the area that I'm dealing with right here. Okay, that I want to be taking a look at. So I've got intersections that I need to find. Okay, but I have multiple. I've got multiple functions that are happening, and I have multiple intersections, right? So I've got the intersection of 8x and 8 over x squared. I've got the intersection of 1x and 8 over x squared. So I have to be able to find those. So they're going to define my bounds of integration. Plus also this function 8x and x intersect each other at 0. Okay, so let's do that. So part 1 is we have to find the points of intersection. Okay, so we've got, let's see, we're going to go y equals 8 over x squared and y equals 8x, y equals 8 over x squared and y equals 1x, and we have y equals 8x and y equals x. Okay, this one's easy. This one happens at x equals 0. We can just write that out. We can see it on the graph. We know when we plug this in, this is going to only be true at that point. Okay, now let's do the first part. So I'm going to go y equals 8 over x squared and y equals 8x. Okay, so my first set of points of intersection, I'm going to do this. So I set these two equal to each other. So I'm going to say 8 over x squared equals 8 times x. Cross multiply and divide, right? So I'm going to cross multiply. I'm going to get 8 equals 8x cubed. I'm going to divide by 8, which gives me 1 equals x cubed. I take the cube root, x is equal to 1. That's my first point of intersection. So right here, that's equal to 1. Okay. My next set, I'm going to do y equals 8 over x squared and y equals x. Okay. So I set them equal to each other. Okay. Cross multiply, I'm going to get 8 equals x cubed. I can take the cube root. X is equal to 2. That's my second, right? And then y equals 8x and y equals x, right? X is equal to 0, okay? Right here. Okay, that gives you my bounds of integration. Okay. All right, now I have to be able to figure out, I remember our area in the plane is the top function minus the bottom function. But if I go, let's see, 8x is the top function up until here, and then 8 over x squared is the top function up until there. So I've got actually two different things that I need to think about. Let's draw them in different colors. So I've got this area here, and I have this area here, right? Because my top function changes, okay? So let's draw this out. Okay, because I've got two different intervals that I'm working with. So let's draw it out. I'm going to go from 0 to 1. So here's 8x, and then 8 over x squared, and then I've got like that, and this is x. Okay, so we said this is the region that we're talking about. So if I go from 0 to 1, my top function is equal to 8x. Our bottom function is equal to, look, it's right here, 1x. Okay, helps to draw things. I like to get the visual on it. Let's do this again. So here's my 8x. Here's my 1x. And here's my 8 over x squared. Here's 1. Here's 2. We did this in green, right? So let's do this part. So on this interval from 1 to 2, my top function, so I'm just looking here. So my top function is 8 over x squared. My bottom function is equal to x. Right, you can see right here, look, from here to here, my top function is this one right there. That's 8 over x squared. My bottom function is this one. That's just equal to 1 times x. Okay, so I have two different integrals that I need to set up and work. Okay, so 2 set up integrals and evaluate. Okay, so let's go ahead and do that. So my first integral, I'm going to go from 0 to 1. My top function, 8x, minus my bottom function, 1x dx, plus, right, this is going to give me both. I'm going to go from 1 to 2. My top function, 8 over x squared, minus my bottom function. Okay, what's required here? I need this line. That's required. What else is required? My points of intersection. Okay. The sketches are just for you. Okay. All right. So let's go ahead and work it out. So this becomes 0 to 1. 8x minus 1x is 7x dx plus 1 to 2, 8 over x squared minus x dx. I'm going to do this offline. I just want to show you, right? What am I going to do here? So if I'm going to integrate 1 over x squared dx, okay, so we can imagine I've got an 8 hanging out here at the end. So how do I integrate that? So I'm thinking this is going to be 8 times x to the minus 2 dx, right? So my exponent is -2, not -1, it's -2, which means I can do the power rule. Okay, so I'm going to get 8 times. My power rule says I'm going to increase this by 1. -2 plus 1 is -1. I'm going to divide by my new exponent. -8 all over x. That's what we get. Okay. I'm just doing this offline so you can see, because I'm going to write it out over here and I want it to be clear. So this is going to become, my power rule says this is 7 times x squared over 2, and I'm going to evaluate that from 0 to 1. Plus, right, we just did this one over here. So this is -8 over x minus, right here, this is x squared over 2, from 1 to 2. Okay. This line here is required. That's your antiderivative. You must show this line here. Okay, you must show that you've set up top minus bottom. Okay, and you must show your antiderivative. Okay, and you must show the points of intersection. Here I'm just going to evaluate it. So this becomes 7/2 plus, I did a bunch of math offline, 7/2 plus 5/2, 7 plus 5 is 12 divided by 2, that's equal to 6. So the total area bounded by these 3 graphs is equal to 6. Okay. Everybody see how we did that? Okay, I'll give you a chance to finish writing that. Okay. So we were talking about things with respect to the x-axis, but I could just as easily have been talking about things with respect to the y-axis, right? So let's talk about integration along the y-axis. Right, so we're gonna need to be flexible, need to be that we can do this. So it's gonna look like here's my x, here's my y. Let's say I've got a function that goes like this. It's a function of y now, g of y. So it's a x equals g of y. It's a function of y. And I'm gonna go from c to d. You can still call it a to b if you want, but we're giving it different variables so that you can conceptualize in your mind. Now the area that we're looking for is the area between the function and the y-axis. It's an awful lot like, if I turned it this way, doesn't it look like what we did just exactly with the function and the x-axis, right? So this is the function and the y-axis. So what does that look like when I go to calculate that? I'm going to go from my smaller number to my larger number. I'm going to integrate my function now with respect to y, dy. Okay. Right. Example 4 is just calculating the area between our function and the y-axis. And then we'll talk about area between 2 curves with respect to the y-axis. All right, so evaluate and sketch. We're going to go from -6 to 6, y squared minus 9. Okay, so I'm going to go ahead and plot this out just because I like to sketch it. Let's see, oops, wrong graph. There, okay. So if you're not sure, right, I would say y squared minus 9 equals 0. I'm going to solve y equals plus or minus 3. Minus 3, positive 3. That's where it's like a parabola, but it's facing this way. Here's our function, right? And now we're going to go from -6 to +6. I'm not drawing this very well. So I've got this region here because it's between my function and the y-axis. Between my function and the y-axis. And let's imagine I drew this a little bit better. I'm sorry. Let's go like this. We'll make this straight. And then I've got my function and the y-axis. So these are the areas that I'm going to be working on. Okay, so when I integrate from -6 to 6, these are the areas that I'm summing up. Okay, so let's go ahead and set this up. So -6 to 6, y squared minus 9 dy. Same fundamental ideas that we did when we integrated with respect to the x-axis. So I'm going to use my linearity, y squared dy minus -6 to 6, 9 dy. Okay, power rule, which gives me 1/3 y cubed minus 9 times y. This whole thing gets evaluated from -6 to 6. So I plug this in, this becomes 1/3 6 cubed minus 9 times 6 minus 1/3 minus 6 cubed minus 9 times minus 6. Okay, and in the end, the answer that I get is equal to 36. Okay, same process, same power rule, same process, everything is the same. It's just with respect to y instead of x. Okay, I have an antiderivative. I've got my function that I'm integrating, my fundamental theorem of calculus, f of b minus f of a, and I get an answer. Okay. Okay, so let's talk about an area between two graphs, but with respect to the y-axis. Okay, so let's draw this out so we can see. So here's my x, here's my y, okay, and here's my c, and here's my d. Those are my bounds of integration. So let's say I've got a function here. This function here is h of y, and I have a function here, right? I'll call this g of y. So the area between these two is this area right here. Okay, I'm going to do this, right? So this is my x-axis, this is my y. Remember what we did when we were doing this with respect to the x-axis, top minus the bottom, okay? This was our top function. So now I'm going to go right minus my left, okay? I'm going to integrate from c to d. I'm going to say function on the right minus function on the left dy. It's the equivalent to the top minus the bottom, but we're going right minus left. Bigger function minus smaller function. You can think about it like that. Okay. And in this case here, we're going to go c to d. So our top function is, our right function, sorry, is g of y minus h of y dy. Okay, area between two curves. Same process that we did with x, but now we're just applying it to y. All right, so I'm looking at example 5. We'll roll through example 5. All right, h of y equals y squared minus 1. G of y equals y squared minus 1/8 y to the 4th plus 1. I'm just going to sketch this out. We're going to go through the same algebra. I just like to look at a picture. Why? This is like a parabola, but it's this way. So this intersects it at 1 and minus 1 here and here. I'm going to draw it out like this. This is h of y. And then g of y cuts in like this. So it's going to go, that shouldn't be, this is a smooth curve. And then down. Okay, so the area between them is this sort of amoeba shape here. Okay, that's the area that we're looking for. I need points of intersection. I need this. It's going to give me that mark. And I need this. It's going to give me that mark. Be careful. Don't get confused and think I'm looking for points that are with respect to x. No, no. All of these are functions of y. I'm looking for my c and my d. Okay, so my first bit is points of intersection of the two functions. So I'm going to set the two functions equal to each other, right? And then I'll solve for y. So h of y, y squared minus 1 equals y squared minus 1/8 y to the 4th plus 1. Okay. I know the y squareds are going to cancel, so I'm going to just subtract everything. okay, from both sides. So basically what I'm going to get is 1/8 y to the 4th minus 2 equals 0. I'm going to solve for y. Okay, so that's going to give me 1/8 y to the 4th equals 2. Multiply. Y to the 4th equals 16. Take the 4th root. That's a 4. Take the 4th root. And y equals plus or minus 2. Okay, so I need this. Right? This is part of what I need to show in order to get full credit. So this is 2. This is minus 2. Let's give me my bounds of integration. Okay, all along this interval, this function here is greater, right? So this is my rightmost function. So my h of y, I'm sorry, that's I wrote that wrong. This should be g. My g of y and my h of y. My h of y is less than. Okay, so I have to go minus 2 to 2. Right function equals g of y, left function equals h of y. Remember, we're doing right minus left. Okay, so I'm going to go minus 2 to 2, right minus left, dy minus 2 to 2. So my right function, g of y, let's write it down, y squared minus 1/8 y to the 4th plus 1 minus my left function, h of y, y squared minus 1 dy. Okay, so this is going to give me minus 2 to 2. The y squareds cancel. Watch out for your negative. You're going to distribute that. So it's going to be minus y squared plus 1. Okay, so then this ends up being minus 1/8 y to the 4th plus 2 dy. Okay, power rule for each of these. So my antiderivative, when I go to integrate this, this becomes minus 1/8 times y to the 4th divided by 5. 1/8 times 1/5 is 1/40 y to the 5th plus 2 times y, and this is being evaluated from minus 2 to positive 2. You need this as your antiderivative. You must show that, and you must show this, which is right minus left. Okay. Points of intersection, right minus left, my antiderivative. Now I can just go ahead and evaluate it. All right, so minus 1/40 2 to the 5th plus 2 times 2. Minus, this is my fundamental theorem of calculus, f of b minus f of a, or in our case, f of d minus f of c. Okay, so this is minus 1/40 minus 2 to the 5th plus 2 times minus 2. Okay, and what I get out in the end is going to be equal to 32 divided by 5. You can give it as a fraction or you can give it as a decimal. Either way is fine. Okay. All right, you guys. I have a couple other examples I'm going to go over tomorrow because I want to spend time on them. They're different types of examples that are going to look at different ways of thinking about these problems. Okay. They actually come from previous final exams, which is why I want to cover it tomorrow. So it'll help us start to review for the final, as well as give ourselves a chance to kind of think about these problems and let it sink in overnight and then go over additional examples tomorrow. Okay. So with that said, do you guys have any questions on homework for chapter 2? I can answer those questions now, or we can talk tomorrow or in office hours. We can end early, either way. 2.1, number 35, sure. Give me a sec to get out my marks. Wait, 2.1, number 35. Why do I not have it? I actually, looks like I don't have it written down. Can I don't have it written down, and I hesitate to do these on the fly so I don't make a mistake. Let me do this. Chapter 2.1, question 35. If you don't mind, I'll do it out because I apparently don't have it in my notes for some reason. I'll do it out and then I'm going to post it online. I'll post it onto our Canvas page. Okay, so take a look for that. Probably during office hours, I'll post that. Okay, so sorry about that. 2.3, number 22. Okay. All right, so chapter 2.3, question 22. All right, so 22 says v of t equals 3t plus 2, and we're gonna look at 4 to 8. Okay, so now it looks like I guess we're asked for, is it the, I actually don't have the question in front of me, so I'm just gonna have to go through. So I'm gonna integrate this, right? So from 4 to 8, I'm gonna integrate 3t plus 2 dt, and I'm gonna be dividing that by 8 minus 4. So it looks like our change in position over change in time, right? So our average velocity, I think maybe is probably what they're asking. So this is gonna, when I integrate this, I'm gonna get 3t squared over 2 plus 2 times t, and I'm gonna evaluate that from 4 to 8, and that's all gonna be divided by 8 minus 4 is equal to 4. So this is gonna be 3 halves. Let's do 8 squared plus 2 times 8 minus 3 halves, 2 squared, oops, I'm running out of space, 2 times 2 all over 4. And this gives me 96 plus 16 minus 24 plus 8 over 4. Which gives me 20. Was that average velocity? So we're looking at meters per second. Oh, you went to 2.3, number 35. Okay. Number 35. All right. Okay. Okay, so not that one. So 2.3, number 35. So estimate using left endpoint sample set. So we're going to do 0 to 1 radical x dx. Our partition points are 0, 1/4, 1/3, 3/4, and 1. So I have to calculate out my delta x's, right? So my delta x1 is equal to 1/4 minus 0, which is 1/4. My delta x2 is 1/3 minus 1/4, which is 1/12. Delta x3 is 3/4 minus 1/3, which I got equal to 5/12. And then delta x4 is 1 minus 3/4, which is 1/4. So these are our delta x's, right? I need those when I calculate the area, right? This is my base, okay? Left sample set, okay? I'm gonna start off at, I'm gonna go 0, because it's the left edge, so that means I include A, right? So I'm gonna go the first one, 0. And then I'm gonna go, my next one is 0 plus my delta x1. And then I'm gonna, which is gonna be 0 plus 1/4, which is equal to 1/4, right? And then I'm gonna go 1/4, this value here, plus my delta x2, right? So this becomes equal to 1/3. And then this is 1/3 plus delta x3, which is 5/12, and then that's going to give me 3/4. So my left sample set is 0, 1/4, 1/3, 3/4, right? So see how I calculate. I had to calculate my delta x first. I start off at A. We're told at the left, so I'm starting off at A. 0 is my first one. 0 plus my delta x1, whatever that value is, plus my delta x2, because that tells me what's the width, right? And then whatever that value is plus delta x3, that gives me my final sample value. These are the values that I'm going to plug into my function. All right, so now I'm going to go I equals 1 to n f of c sub I delta x sub I. So we're going to sum up all these areas of the rectangle. So my delta x times my function evaluated at these values here. So it's going to be f of 0 times 1/4 plus f of 1/4 times 1/12 plus f of 1/3 times 5/12 plus f of 3/4 times 1/4. Okay. So this becomes radical 0 times 1/4 plus radical 1/4 times 1/12. Don't put these in, these are separate. This is radical 1/3 times 5/12, right? This is the height times the base. Radical 3/4 times 1/4. And I suggest doing these individually on your calculator and then adding them up, okay? If you try to do this all in one stream on your calculator, then sometimes you don't type in the wrong numbers or you miss a parentheses and then your answer gets all messed up. So this rounding up a little bit was 0.498. Okay. All right, you guys. Okay. All right, guys, I hope you guys have a great day. Oh, sorry, 2.3, I'm cutting off. 2.3, number 14. One more question. We'll do this one and then we'll take off. All right. All right, so chapter 2.3, question 14. Okay, so 14 says average value on the interval. So C of x equals -10 and our interval is -11 to 9. So I'm going to integrate -11 to 9 of -10 dx. So -10x evaluated from -11 to 9, right? But then it's an average value. So I have to divide it by my range of values. I'm going from 9 to -11 to 9 gives me, 20 different values. So divided by 20. So this is going to become -10 minus 10 is -11 all over 20. So my average value -200 over 20. Our average value. We needed, like you're summing up all the terms and dividing by the number of terms that you have. That's how you want to think about it. Summing up all the terms, dividing by the number of terms we have gives us an average value. So our average value is -10. Okay, guys, I'm going to end there. If you guys have any other questions, just come to office hours and we can talk it through. Okay. Bye, guys.
Thank you.
Have a great day.
Thank you.
Thank you.
Bye.